Hello everyone, my name is Neha Kardam and this is the second lecture on Introduction to Microprocessors. In this lecture, we are going to learn about some important key terms in the microprocessor. So let's get started. So these are the some of the key terms which are mentioned here, and you might be familiar with some of it. For example, the hardware, which is the physical parts that make up a computer or electronic system. So in your electronics lab, you most of the time deal with the hardware parts in any lab experiments. So that's your hardware part when you deal with like wires and connecting them together and following some schematic. Whereas the software it basically executes a set of commands and which basically performs a useful function, and sometimes the softwares they integrate with the hardware, and then hardware performs whatever the instruction set has been executed. And then we have a firmware, which is a software that is stored in a non-volatile memory. You can think of this firmware as a permanent software which is programmed into a read-only memory. And in electronic systems and computing, these firmware they have a specific class of computer software which provides the low-level control of the for the device's specific hardware. And then we have instruction set. So the instruction set is basically a list of commands that are associated with actions in particular piece of hardware to execute. So let's read here. Don't confuse with instruction set with a programming language like C or BASIC. So yeah, they are quite different than your C language programming. And these instruction set, which I'm talking about here, are very different in assembly language, and we are going to learn like how they look like in the next coming lectures. So for now, you understand that these are some set of command, and there is a list of instruction sets which are there in a microcontroller. If you read the data sheet, you will get to know that they have like different instruction set which are used to create the programs in the assembly language. Now we are going to see the example of instruction set. So as I said before, instruction set is the group of commands that a microprocessor is designed to use for the manipulation of data. And here you see is an example of instruction set here is given. So these are the instruction set you see here. And then we have instruction opcode and then here also, and then these are the instruction what they are supposed to do. So right now we are not getting in detail of what each these instruction sets mean. I just wanted to give you an example. We will get in detail of some of the instruction set for the microcontroller which we are using, and you will get to know the function of each of them with examples. Now next we have instruction set. So now we are going to do a small activity in which we are going to assume we are going to assume a robot which is going to follow these 4 instruction set. And so you have to imagine that a robot is going from a start point to some end point, and it is covering a path, and you have to write that path using these 4 instruction set. So I would say you can pause the video and you can make your own instruction path for the robot using these 4 instruction set. Now let's see what instruction set I have used for the robot. This is a robot with 2 wheels, and let's see. So we are using forward, reverse, right turn, and left turn. So if your robot is supposed to follow this instruction set, then which means like it's going to go forward and then reverse and then right turn and then left turn. So this right turn is according to robot's position. So and then the left turn. So all in all, looks like it's going to come into this position or not. What do you think? So think about it. So let's go to the next slide. So the instruction set which we have used previously, they don't mean anything without a value to act on. What does it mean? It means that let's go back to the previous slide again. So you see that there is no value is assigned to these instruction set, which means the robot doesn't know actually to how much step it's supposed to go forward and reverse back or to take the turn right or left. So we are missing that valuable information. So let's see if we have that information and we put that into our instruction set. Let's say forward going 10 centimeter and then taking a left turn of 90 degree and then left turn again of 90 degree and then taking a reverse of 10 centimeter and then taking a right turn of 90 degree. So if you have instruction set like this, then the robot will know exactly position where it has to go. So these values are very important when you give the when you write the program. So this is just an example, but but this example signifies like how these values are critical to your program. Now notice that I arranged the instructions in a particular order to get the robot to move where I wanted. So you saw that this was my order. Like I first kept forward at 10 centimeter. This was my first step, and then second step was to take the left turn of 90 degree and then take another left turn of 90 degree and then do a reverse of 10 centimeter. So and then right turn at 90 degree, and whatever the position it has reached, that's going to be the final position. So you can try these steps on your robot and see where your robot reaches to a point. So this order you see here is very critical in writing a program, and this order is basically called your algorithm. So this is my algorithm for this tiny robot. So let's see further. So an algorithm is basically a step-by-step procedure for solving a problem, and in our case it was moving the robot. But algorithms are used in more than just robots, and in other words, we can also say that an algorithm or a series of algorithms using the instruction set of a microprocessor that provides command to a system for doing something useful. So this definition is not entirely correct, or perhaps you can say too correct to be acceptable to people in the PC world. Now let's take a simple math problem and see how we are going to write algorithm for that. So let's say if you want to multiply 14 times 5. So what we are going to do is first we need to take this first column, which means this one. So these are two columns, this first and then second. So we are going to take this number and then multiply to this column, which means to the 4, and then see the result. So 5 multiplied with 4 is 20, and then next step would be multiply 5 with this column.
So it's going to be 50, okay, because this is not included. Either you can put like a crosshair or 0, it's the same thing. And if you multiply, you will get this, and then the answer is going to be 70. Okay, so we know this thing. Our question was this, to multiply 14 by 5, 14 times 5, and then this is our solution. So we know this part. So this algorithm we should follow. Now, what if we make mistake? What will happen? Let's see how we can make mistake. So to multiply 14 times 5, what if you multiply 5 with this column first? So if we multiply with this column first, we're going to get 5. And then if we multiply 4 to this 5 to this 4, we are going to get 20. And if we add them up, this is going to make 25. So here you see, by a single mistake, the whole algorithm is wrong, and it's giving us the wrong result. Okay, so we have to make sure that whatever the algorithm we are writing is correct, and we should go through the each step, like what result it is producing. So this example is a very simple example I have provided. You will be dealing with more complex problems in this class. So now note some key points here. Note that the only difference between my algorithm on the last two slides was where I defined first column. So yeah, so it's critical to know like which one is my first column. Is that let's go back again. So is this my first column or this my first column? So it depends what you define in your algorithm. So for English speakers, the normal order of reading is left to right. We make assumption based on what we humans know that computers can't. So computers cannot assume, they simply follow the instructions. So whatever instruction you write on your program is simply going to follow that, and no assumption is made by the computer. So you have to be very, very careful when you write the program. So this is all about algorithm, and we covered some key terms in this lecture. Now we will be covering the block diagrams in our next lecture. So this is the end of the lecture. Thank you so much for watching.